Hey everybody, this is Mr. Beckstrom, and today I want to go over an example from section 7.2. This is number 2, and it says solve the triangle with the given information here. So they have a triangle here, 3 sides, A, B, and C, and 3 angles, alpha, beta, and gamma. I like to use capital A, capital B, and capital C. They're using the Greek letters. Alpha is the first letter in the Greek alphabet, beta is the second letter, and gamma is the third letter. It's kind of equivalent to like an uppercase C. You can use either of the sets, either capital A, capital B, capital C, or alpha, beta, and gamma. It's really the kind of the same thing. But let's go ahead and get started here. So I'm going to off to the side here. I'm going to go A, B, C, and then alpha. I'll go ahead and use what they're using, and beta and gamma. All right. So what they give us a 6.1. And for C, it's 2.3. And for beta, it is 12.8 degrees. And I'm also going to go ahead and kind of fill in here what I have. So I have a 6.1 here. I have for C, I have a 2.3. And for beta over here, I have a 12.8. 12.8 degrees. Now notice that I have 2 sides and I have an angle between those 2 sides. So this is called a side angle side triangle. That means I have 2 sides with an angle in between. Now when I have this, if I were to try to use the law of sines, I would at least need to know one angle with the opposite side. But notice that I don't know any angles and their opposite side. So I don't know beta and little b. I don't know gamma and little c. And I don't know A and alpha, right? So I don't know any sides and their opposite angles. So um, I cannot use the law of sines in this case. So what I'm going to have to do is I'm going to have to use the law of cosines. And there's 2 cases usually where I have to use the law of cosines. And that's when I have the side angle side. That's where I have 2 sides and an included angle. And the other case is when I have 3 sides and no angles. So those are the 2 times when I start off with a triangle and I don't have a side and its opposite angle already known. Okay, so how do I use this? Well, I'm going to start off with the side that I don't know. So in this case, that is the b over here. So I don't know the b. So it's going to look like this. So b squared is equal to the sum of the other 2 sides squared. So that's going to be a squared plus c squared minus 2 times those 2 sides times a times c times the cosine of the side that corresponds with my original side here. So that would be the times the cosine of beta. All right, so now we have 3 different formulas depending on which side we don't know. So if we don't know C, then we basically start with the C over here. If we don't know A, then we start with the A over here. So you can write it 3 different ways depending on which of the 3 sides that you don't know. Since we don't know the B side, we start with the B over here. So it's the side that you don't know squared equal to the 2 sides that you know, the sum of those squared, minus 2 times the 2 sides that you know, the product of those 2, times the cosine of the angle that you know. Okay? All right, so once we have this formula set up here, it's just going to be a lot of plugging in and solving at this point. So let's go ahead and do that. So we have b squared is equal to a squared, so that's going to be 6.1 squared plus c squared, so that's 2.3 squared minus 2 times a, which is 6.1, times c, which is 2.3, times the cosine of 12.8 degrees, 0.8 degrees. All right. So now b squared is equal to, I'll do an approximation here because it's probably not going to be something perfect here. Let's make sure that we are in degrees because they gave us degrees. All right, so and then plug all that in. So 6.1 squared, wrong thing, 6.1 squared plus 2.3 squared, 2.3 squared minus 2 times 6.1, 1 times 2.3 times the cosine of 12.8, 12.8, and we're going to get this here, and then I'm going to end up taking the square root of both sides. Then I'm just going to do second square root of that last answer, second answer, and I'll get that. So this first one is going to be about 15.1373, and then you take the square root of both sides, so b is approximately equal to 3.89. 3 point, and we'll round that to 1 decimal place just like the others. So b is 3.9, and so we got our b. Now we need to find either alpha or gamma here, and let me just make sure how many decimal places. Yep, they said round to 1 decimal place is needed, so 1 decimal place there. So now in order to find the next angle, since now we know an angle and the opposite side, because we know b now, we can go ahead and use the law of sines. So now I'm just going to set that up. So that's the sine of 12.8 degrees over its opposite side, which is 3.9, is equal to, let's go ahead and use the sine of, usually the side, I think from the largest side here, so the sine of alpha all over 6.1. And if you cross multiply and divide, you will get the sine of alpha is equal to 6.1 times the sine of 12.8 all over 3.9. So alpha is equal to the inverse sine of that. So let's put in the inverse sine of that into our calculator. So, and make sure that this is degrees here. So make sure that we are, yeah, I didn't change it out of degrees yet. So inverse sine of this whole thing here. So 6.1 times the sine of 12.8 divided by 3.9. And I did not put the entire top in parentheses because it'll do that in the correct order of operations. All right, and what do I get? Now I get 20.3, so I'm going to get 20.3. 20.3. Now remember, with the inverse sign, I also have to look at 180 minus 20.3 as a possibility. So I also have to look at 180 minus 23, 20.3 as a possibility. So that's 159.7. So also 159.7. So both of those are going to end up being possibilities here. And then for the last side here, but that side is really small there, right? So it's going to end up being that 159.7. So that's going to be, hold on just a moment, 159.7 degrees, and I think we should have gone with the smaller side first, but let me just double check here. And 180 minus 159.7 minus 12.8, 12.8, and 7.5. Let's see if this works out. 7.5. Yes. And this does work out right here. So why did we not go with the 20.3? So let's kind of go ahead and ask that, because that's the first one that we got. Notice that how long this side was here and how small this angle turned out to be. Remember, when we take the inverse sign, we have to look at both that angle and 180 minus that angle, because it could be either one of those. And this was a very large angle here. So it's definitely the second of the two. So it's definitely the 180 minus that angle in this case. Well, probably what we should have done here was go with the smaller angle first and then found the larger angle last. So if we found gamma first and then found alpha last, we probably wouldn't have got fell in that little trap. But we still did it this way. And then these should be all of the correct answers here. All right, so kind of a long process here. Not too many questions in this section, but this is how you go about finding it. Just remember that when you take the inverse sine function, you have to look at both that angle and 180 minus that angle and see which one fits your triangle. And remember, when you're done, the largest angle should be opposite your largest side. Your smallest angle here, which is 7.5 degrees, should be opposite your smallest side, and your medium angle should be opposite your medium side. So if we had gone with the 20.3 for our alpha, then that would have not worked, so we would have known that we picked the wrong angle. All right, guys, I hope this helped, and if you have any questions, let me know, and I hope you all have a great rest of your week. Thanks.